This lesson is for Chapter 1, Section 4, Quadratic Equations and Applications. So please open up your notebook and your textbook. If you want to be with me on your textbook, we are on page 100, I think. Yep, page 100. All right, so we can solve quadratics in three ways. Solve by factoring, solve by graphing, or solve using the quadratic formula. Solving by factoring, first we're going to factor the polynomial. Second, each of the factors that we get will be set equal to 0 and solved. And those zeros are going to be the solutions for that quadratic. So taking a look at this one as our first example, solve 2x squared minus 3x plus 1 equals 6 by factoring. First thing we need to notice is that we have a term on the right-hand side. If we're going to solve by factoring, we need to bring that to the left with everything else. So the polynomial that we're actually looking at is 2x squared minus 3x minus 5 equals 0. So now that we have it equal to 0, we can do our factoring and find our solutions. So factoring, there's only one way to break 2x squared. So I'm going to put a 2x in one spot and an x in the other. And with negative 5, I know I'm going to use 5 times 1. I just need to figure out which one of them will be my negative and which one will be my positive. Turns out if I put the negative 5 here and the plus 1 here, I'm going to get that negative 3x term in the middle. Now I've got my factors. I can go on to find my solutions. So my first solution, take your first factor, set it equal to 0 and solve. Move 5 to the right. I get 2x is equal to 5. Divide off the 2. One solution is 5 halves. The next factor, and you may or may not have to set this up and solve, but if we subtract 1 from both sides, we find x is equal to negative 1. Most of you can see that from the x plus 1 factor that a negative 1 will make that equal to 0. Another way of factoring to solve involves extracting square roots. If the equation is solved so that the squared term is set equal to an amount, square rooting each side can find your solutions. So in other words, if you can isolate your squared term to the left and have numbers to the right, no variables can be over there, numbers on the right, we can do the square root of both sides to finish finding our solutions. So take a look at the example on the slide. Notice how the left-hand side is a squared variable term, and then the right-hand side is 10. If I took the square root of the left and the square root of the right. Now remember, for every integer, there's going to be a positive root and a negative root, so we need to include them both. I can solve for x this way. So the square root of my left-hand side is just x minus 1, and then I have plus or minus root 10 on the right. Solve or finish solving by getting rid of the plus 1, so add 1 to both sides. I guess we're getting rid of a negative 1 by adding 1, sorry. And there's your end answer. 1 plus root 10 or 1 minus root 10. Completing the square. All right, so this is my attempt at giving you steps that you can follow that are typed out. Okay, I'd like you to pause right now so you can write these steps down, and then we're going to give them a shot and put them into play with a couple of examples. So if we were going to solve by completing the square, okay, looking at this problem as it is, we don't have a perfect square polynomial here, so we can't break it into squared terms or doubles. So we're going to use this process of completing the square to do so. I'm going to get rid of the 1. So add 1 to both sides, and I leave a gap there because I'm going to be creating something in that spot that will allow me to factor the left-hand side into a perfect square factor pair. So I leave the hole there. Now, The process that you've copied down already tells us to take half of the x coefficient. All right, so the x coefficient on this problem is -4. Take half of it. That's -2. Now the next step says to square it. Well, -2 squared is 4. If I have a 4 in this spot, I'm going to have a perfect square trinomial, and I'm going to be able to factor it into identical factors. Now, you guys all know from algebra that if you're going to add something to one side of an equation, you have to also add it to the other. So put a +4 on the right as well. Now factor. If we factor that trinomial, we're going to have an x minus 2 and another x minus 2. That's what we were going for. We wanted to be able to factor it into a squared term. So rewriting that, I'm down to this. Now we can use that extracting the squares concept from our previous example to finish. So I take the square root of the left, and I also find the roots of the right. Square root of x minus 2 squared is x minus 2. Finish by adding 2 on both sides. And we're done. Sometimes when we try to complete the square to factor a polynomial, the lead coefficient isn't a 1. All right? In order for completing the square to work, it needs to be. So on this problem, we have a little work to do before we can start that process. We need to get rid of the 3. So if we divide all the terms in our polynomial by 3, we will have a 1 lead coefficient. So I'm going to start by doing that. I'll have x squared then minus 10/3 x minus 2/3 equals 0. Okay, now the process is the same. Yes, you're going to be working with fractions. You'll be all right. So my next step tells me to take your x coefficient, which on this problem is -10/3, and find half of it. So I have -10/6. The next thing to do after taking half of the x coefficient is to square it. So I take -10/6, then I square it, and I get 100 over 36. So over here, first thing, get rid of the 2/3 that was in that spot. So kick it over to the right-hand side, add 2/3 to both sides, and insert the 136th that we just calculated. Okay, so now we can do our factoring. Believe it or not, this is real simple because you've already done the hard work. That was the half of your x coefficient. That's going to be the number that is in your factor pairs. Okay, over here we do have a little bit of work to do. We need to add those together. I'm going to go ahead and make my equivalent fraction so I can add. So I need my bottom to be 36. My top's going to be a 24. I end up with 124 over 36. So we have x minus 10/6, 2 of them squared, is equal to 124 over 36. I extract my squares. So the square root of this and the roots of 124 over 36. Okay, so the square root of the left side is x minus 10/6. I'm going to simplify here a little bit already. The square root of 124 over 36. Come up to the side here and look at what I do. Square root of 124 over square root of 36. Well, the denominator flat out solves, right? Now 124 is not a perfect square, but it can be broken. We can break that into a 4 and a 31. 4 is solvable. So the numerator becomes 2 root 31. So bring that back down to our problem. Last step is to get x completely alone. So we're going to add 10/6 to both sides. Okay, come over here. I'm running out of room. We end up then with x equals 10/6 plus or minus 2 root 31 over 6. There's some reducing to do. The denominators match, so the numerators can be written together. Whoops, I need my 2 there first. There, I think I got it all. Now look at your numbers. Okay, both of the terms in the numerator have a factor of 2. So we can divide everything by 2's and simplify down to this final answer. A lot of steps, a lot of rules of math from years past brought back in, our fraction work and so on, but the steps are the steps. Okay, so this one had more work because you had more to do to get those numbers simplified, but the steps behind the completing the square were the same. Solving with quadratic formula. You guys have more experience with this one than a couple of those other ones. Just a few reminders. In quadratic formula, okay, negative b plus or minus the square root of b squared minus 4ac all over 2a. Where do the a's, b's, and c's come from? They come from your quadratic written in standard form. So a is always the coefficient of your squared term. B is always the coefficient of x. C is always the constant, the number that stands by itself. Now, if some of those things don't exist, remember then that that means that A, B, or C might have been a 0, and that's why that term is not in the problem. Okay, so just a few reminders to keep in thought. The discriminant, which is the b squared minus 4ac part, is really important to us in math for a few different reasons, and this is why. If you get that part solved, b squared minus 4ac, and you have a positive number, we can find roots of positive numbers. Okay, every positive number, and we talked about it already today, every positive number has 2 roots, a positive and a negative version. So if your discriminant, if your b squared minus 4ac is positive, you will have 2 answers. If that discriminant is negative, you'd be asked to be finding a square root of a negative number. That is undefined. Okay, you can't find square roots of negative numbers. Those are imaginary. So there are no real solutions to that quadratic. If the discriminant is 0, okay, the square root of 0 is 0. You're going to have only one solution to that particular quadratic. Okay, so these are some good things to keep in mind when you're working the quadratic formula. If that square root part, the discriminant part, ends up being positive, you're going to get 2 answers. If it's negative, you're done. There are no real solutions at that point. If you get 0, you're only going to be coming up with one answer, because plus or minus 0, you're going to get the same thing. So let's use the quadratic formula. So on this problem, a is 3, b is 2, c is a negative 10. Okay, so negative b plus or minus b squared minus 4ac all over 2a. We'll fill it in. Negative b is negative 2. B squared is 4 times negative 4 times 3 times negative 10, and then all over 2 times 3. Now underneath the square root there, okay, this is where things end up going wrong generally, if they go wrong. Underneath there, you have a negative 4 times a 3 times a negative 10. In that series of 3 things being multiplied, you have 2 negatives, and that turns positive. Okay, so watch for that. Negative 2 then, continuing on, we've got square root of 124. We actually just had square root of 124 in our previous problem, so if you remember, that simplified down to 2 root 31. Both terms in the numerator have 2's that can factor out, so we can divide them with our denominator, and we ultimately end up with negative 1 plus or minus, plus or minus root 31 over 3. All right, I decided to do a couple of the word problems, a couple of the checkpoints that are in your textbook. So I started with checkpoint number 7 at the bottom of page 106. Okay, there's an example above it as well. That's in your book for you already, so we're going to do the checkpoint to have another example in your notes. A rectangular kitchen is 6 feet longer than it is wide and has an area of 112 square feet. Find the dimensions. All right, so we know it's rectangular. We know a little bit information about the length. We know nothing about the width. So assign a variable to width. Okay, now use the clue, 6 feet longer than it is wide, to come up with an expression for the length. If it's going to be 6 feet longer than the width, W plus 6 is an expression that does that. Now you have to think back, how do I find the area of this thing? Well, of course, area is length times width. So our area is going to be W times W plus 6. The problem tells us that we're going to come up with an area of 112 square feet. Now I can do my math. I can distribute the W. If I bring 112 over, I end up with a trinomial that looks factorable. So play around with factors of 112. You will find out that 14 times 8 is 112. So if we go with a positive 14 and a negative 8, we'll get that positive 6W term. The solutions to our factors. The solution on this one is a negative 14. The solution on this one is an 8. Well, the width of a rectangle cannot be negative. So we know negative 14 is not the width we're looking for. 8 is. So our width is 8. Our length is 6 longer. So we know our length is 14. So 8 feet for width, yep, and 14 feet for length. Checkpoint number 8. Checkpoint number 8 uses a position formula. This is described to you at the very top of page 107. So if you don't know what the variables are indicating, look back to that paragraph up there and it'll help you remind you what the S's, the V's, and the T's all stand for. Now the problem itself says you drop a rock from a height of 196 feet. So that rock is starting at an initial height of 196. So S sub 0, which stands for initial height, is 196. How long does it take the rock to hit the ground? Well, if you're going to drop it, you have an initial velocity of 0. It wasn't moving. It was in your hand. So we can take these things now and we can fill in what we know. And if we're looking for how long, that would make sense then that we do not have anything to plug in for t. So plug in what you've got. So 0 times t, we can get rid of that. And it's going to hit the ground. So our ending height is 0. So I suppose I should just add that on. Looks like we've got a quadratic. We've got the t squared term in there. There's only 2 terms, and I don't see like difference of perfect squares maybe, or it's negative right now. I'm going to move my negative 16t squared to the left. Okay. Now if I were to get rid of the 16, I would have isolated my squared variable, and I can then extract the square. So that's what I'm going to do. I'm going to divide both sides by 16. So now I have t squared is equal to 196 over 16. So if I take the square root of both sides, now this time I'm not going to consider the negative root because time can't be negative. So I'm just going to write it like this. T is equal to Well, the square root of 196 is nice. It's 14. Square root of 16 is nice. It is 4. So reducing 14 fourths, I find that it's going to take 3.5 seconds. All right, that's it for me. Take a look then at the assignment problems that are on 110 to 112. Work a lot of them. The best way to get these processes down and to understand them better is to practice more so that you're comfortable with them and you don't need to keep looking back at steps or other examples that are done. So ask questions in class, and we'll see how this goes for you guys.